Hi guys, I'm Santosh. Giving the demo on why on IBM virtualization. Why virtual? I have a industry experience of 8 years, and I have worked on multiple platforms like data center, architecture, data center. We have set up the data center for the We have built so many VIO servers. We have built so many high availability servers, efficient servers. So today we will discuss about why why VIO servers and why it is required. What is needed? Need for the VIO server is a very strong requirement is reduce cost and optimize the investment. Whatever you are investing on the hardware. Server side, this normally means continue to provide same or better kind of the performance, reduce software cost, reduce hardware cost, increase global security, use avoiding overload, optimize resource allocation to application for configuration, dynamic reconfiguration solution, partition virtualization. So very strong reason is the cost, minimizing the hardware cost. So assume that you have a hardware with some terabyte of RAM, some processors, and some other devices. So if virtualization is not there, so that single hardware you can use for single application. You can use single application. So how I can reduce the hardware cost? We will discuss creating the LPARs and micro-partitioning with the help of virtualization technologies. What is partition? Partition is it may be hardware partition. Hardware partition means it's like your blades, blade center, X-series, servers. So what is blade? Blade is nothing but it's having its own processor, own RAM, and own IO slots. Why it is used to host the single application. So it is called hardware partitioning. What is software partitioning? Software partitioning again it is a SCSI server. So you can install the hypervisor on SCSI server and on SCSI server you can create virtual VSCS. So this is bare metal hypervisor. And third type of hypervisor is partitioning firmware. So the hardware based hypervisor. What is hardware based hypervisor? Hardware based hypervisor it will come in built-in hardware in firmware chips. So using that hardware or using that hypervisor, you can create multiple virtual machines in the firmware chip. So IBM is using this technology for logical partitioning. So it is called partition firmware, and so we can create a LPAR on the top of hypervisor, and my physical resources is allocated individually to the respective LPARs. So this is the partition technology. What is LPAR and dynamic LPAR? So what is the benefit of having hardware based hypervisor? Standards, it is the standard on all new systems, P series system, whole processor allocation in LPAR. So what I can do on the top of the hypervisor, I can create a logical partition and I can allocate memory, I can allocate processor, I can file source. So that will act as a dedicated for that particular network. So this is called LPAR. And what is the benefit? So if any partition requirement is there, any resource requirement is there, on the fly I can move the resources from one LPAR to another LPAR. That is called dynamic. That is called dynamic. So all these features or all this configuration I can do with the help of agency. If agency is not there, I cannot perform any activity. So this is called dynamic and LPAR and dynamic LPAR. What is micro-partitioning? Micro-partitioning is the entitled capacity in unit of 1 divided by 100 of CPU, minimum 110 of CPU. CPU, it may be capped or uncapped, and it is again depend on the weight. So we can share or prioritize or surplus the capacity changes are dynamic. So what is micro-partitioning? Micro-partitioning is that, so it is possible in micro-partitioning that I can share my physical CPU in fraction. As per the workload, I can share the CPU. Suppose, take the example, there is a test server and you are not using micro-partitioning. So for the test LPAR or the test server, I need dedicated resources. So what is required? I require dedicated processor, I require some kind of RAM, I require IO slots. So IO slots I required one for disk IO and one for network IO. So what is the benefit of having micro-partitioning? Suppose, assume my test environment requires only, it's having low burden on my processor. It is utilizing only 20% of CPU, not more than that. So, but for the 20%, I am wasting my whole CPU. That means, what is micro-partitioning? So, as I have discussed earlier, so suppose it is my test server, and the test server is not requires too much CPU, and if I don't have micro-partitioning feature, that means I need to invest one physical CPU for my test environment and some RAMs and some IO devices. So if requirement is 20%, I am investing 80% of CPU. So what is the benefit of having micro-partitioning? I can share my CPU inflection as per the work. Okay. So entitled capacity in unit of 1 divided by 100 of CPU, minimum 110 of a CPU. CPU may be capped or uncapped. There is an effect of capped and uncapped partition definitely, and it is again on the weight value of the part. So as a workload, I will schedule my CPU. If the 20% CPU is required, so I will give 0.2. This fraction I can allocate the CPU to my. This is because of micro-partitioning. So what other features I am getting? Cap and uncapped partition. What is cap? Cap partition not allowed to exceed its capacity entitled. Every LPAR must have some value to run the codes and to run the application. So there are some more so to say. So if I assign the 20% of the CPU and the CPU is not sufficient, and if it is in cap mode. So I can that my processor cannot take the advantage of those which are available. That is called cap partition. So that is the drawback of cap partition. So I cannot extend the beyond of the capacity. So what is the benefit of having uncapped? Uncapped, if your partition is uncapped, so I can go beyond what you are assigned to my as one. Suppose our production server require more CPU cycle and that more CPU cycles are available in pool, and if the priority of the server is high, then that extra CPU cycle load. Shared processor LPAR SCSI partition example. Work can be prioritized to give time critical tasks a high fraction of resource. Lower priority partition can run with less dedicated resource but can suck up their CPU cycle. As I have already discussed, that as per the workload, I will assign whether it will be cap partition or it may be an uncapped partition. Those having the uncapped partition that can take the advantage of spare CPU cycles, the CPU cycles available in use. That is the benefit of having uncapped partition. So same they have described here. OLTP partition. OLTP means online transition, and some batch partitions is there. So high interactive load get precedence when needed. Means suddenly my loads increase, and I have assigned my LPAR processor. It is 5% and it is uncapped partition. So if the processor cycles are available in my pool, automatically my processor will get that extra power and my whatever the workload is on the server will be minimized. So when interactive load is low, batch partition uses available resources. So there are two partitions here, OLTP partition and batch partition. So what is happening here? Suddenly OLTP partition requires more CPU cycles. So automatically it is getting the more CPU cycles. So batch partition requires the lower CPU cycles. So automatically it is getting the lower CPU cycles. How it is possible? Because of shared environment and because of micro-partitioning. So sometimes batch partition require more CPU cycles. So automatically from the shared CPU pool, automatically it will get the more CPU cycles according to the load. What is the value of virtualization? IBM virtualization. What is the benefit we will get? It will help you to improve cost and speed, right? Because 100% I am utilizing my hardware. Why? Because I am paying for the hardware, and that hardware you are using only 20%. That means 80% you are wasting. So instead of that, I will go for the virtualization. I will share that resources with another. So allow easier provisioning, management and deployment. So allow easier provisioning means as per the workload, automatically all the resources on the fly, no need to take the downtime. On the fly I can increase and I can decrease. This is the benefit. Changes are transparent to users, which help improve the efficiency. Right? Changes are transparent to users. As I increase the CPU cycle means, as I increase the CPU cycle, immediately that CPU will be available to application and my workload will be shared. Before it was having one CPU, and as I automatically add two CPU, that means that workload is divided into two CPU. The execution of process will be fast. Execution of the process will be fast. Right? So that changes are transparent to users and which help to improve it. I will definitely my application. So with the help of virtualization, what other factors are there? Advanced power virtualization. What is advanced power virtualization? That is micro-partitioning. What I am getting using the advanced power virtualization, that is called APV. I am getting micro-partitioning, Partition Load Manager, PLM, VIO server sharing of virtual devices between LPARs, adapters and devices. All are chargeable features. What I will get? Virtual SCSI server, virtual SCSI client, virtual Ethernet, virtual shared Ethernet adapter, and virtual LAN. These features are available if you have an advanced power virtualization license. So, what is the benefit of advanced power virtualization? We will discuss. Consider there is no virtualization. So, every server or every LPAR is required, every OS is required its dedicated network adapter, physical network adapter, and physical SBA. What is SBA? Host-based adapter. It will bring the SAN to my server. Every LPAR, see, this is one partition, this is one partition, this is another partition, this is again one partition, this is another partition. So here if you will find every partition is having its dedicated network physical card, dedicated SBA or SAN card, FC card we can say, and boot disk. Boot disk, what is boot disk? Some local disk are there. So some disk are coming from the SAN and some of the local disk is there. So dedicated IO cards I require, okay, to create the LPAR. See, every LPAR is having its network card and its SBA card. Network card and SBA card. So this is no virtualization, right? So I require dedicated IOs. So my cost will go high. Cost will go high. Anyhow, you have a micro-partition license, but you don't have advanced power virtualization license. So you again require IOs to be dedicated on your server. So what is the solution for that? Solution is virtualization. Advanced power virtualization. How it will work? So whatever the resources here, network card and this physical SBA card, I can virtualize and I can assign to multiple logical partitions. So I don't require to buy physical IOs for each and every LPAR. So what is the benefit? Benefit is that I have minimized my hardware cost with the help of advanced power virtualization. Right? So this is the benefit. So what is virtual IO? Virtual I/O means the network physical card and HVA physical card I will virtualize and I will assign to whichever. I don't need to buy individual physical adapters for my LPARs. So what is the virtual I/O? It will allow sharing of network and storage devices. Vital for shared processor partitions. Right? I have micro partitions, but still I am not able to minimize my cost. Why? Because if I don't have a advanced power virtualization license, still I require dedicated network and SPA cards. So what is the solution? Solution is overcome potential limit of adapter slot due to high number of possible microparts. Right? Still I have a micropartition, but still I require IO devices, and to connect the IO devices I require to purchase the IO driver box from the IBM. So my server will go use like a so the benefit of virtual IO is that overcome the potential limit of adapter, right? Overcome the potential limit of adapter slots due to high number of possible micropartitions. So same physical adapters I am virtualizing and I am assigning to each other. So allow the creation of logical partition without the need for additional physical resources. Additional physical resources that require the IO, right? Network IO and disk IO. Allows attachment of previously unsupported solution in selected OS client. So previously unsupported, some of the OS will support some of the cards, right? Some of the hardware. So that issue will overcome when I use the virtual. When I use the virtual. So this is my shared environment. Shared in the sense same network card and same HVA card I am virtualizing and sharing with multiple LPARs. It may be your production environment, it may be your test environment. Okay. Virtual Ethernet. How I will virtualize the Ethernet? Configured like a standard Ethernet. One partition may have multiple virtual Ethernet cards. That is the benefit. That is the benefit. So, like a standard Ethernet, my virtual Ethernet card also act like a standard Ethernet card. And there is no cost. Why? Because I am virtualizing. So, multiple virtual Ethernet card I can assign to my card. That multiple virtual Ethernet card may communicate with multiple VLANs, or I can use it for more bandwidth, or so many purposes I can use. So a virtual Ethernet support up to 20 VLAN means my single virtual Ethernet card it will support 20 VLANs. IO server partition provide. So my virtual 20 VLANs, my virtual partition will support CD. This is my one LPAR, this is my second LPAR, this is my third. What I have done? I have advanced power virtualization license, so I have virtualized my Ethernet card. Each are having. This is the virtual switch I have created in the hypervisor. This is the one more benefit of having hardware-based hypervisor. I can create 4095 virtual switches and virtual switches and support software. So multiple virtual switches I can create, and that can host multiple VLANs. So According to each VLAN, I can create my virtual Ethernet adapter assigned to the particular switch. So, what is the benefit? Benefit is that I don't need to invest for physical adapter, physical network adapter. Okay. So, I have assigned virtual adapter on my LPAR. That LPAR will only communicate within my frame. How it will communicate? It will communicate with the help of hypervisor. Hypervisor will take the packet from one LPAR and will check whether the VLAN tag ID is tagged or not. It is tagged or untagged. If it is tagged, then the packet will come along with the VLAN ID. Right? If it is untagged, that means LPAR will send the packet to hypervisor switch. Hypervisor switch according to the VLAN, it will assign the VLAN ID to that packet and will send to respective LPAR. But it is within my server box. It is within my physical server box. But I have need to take the remote connection of this LPAR from outside, right? And all are virtual world here. So from outside, I will not be able to directly access. What is the solution? Solution is you require the VIO server. What is the role of VIO server? So my VIO server will have my physical resources. What is physical resources? It will have the physical IOs. Which IO it will have? It will have physical Ethernet card and physical FC card. Right? So that physical cards it will connect to my physical network switch. So I require the mediator in between my virtual LPAR and my physical outside. So VIO will play that role. What it will do? Since all the physical adapters and all the IO adapters I have given to my virtual server, right? So I will create a bridge on my virtual server so that VIO server it will communicate with my physical outside world and my virtual inside world. Physical outside world and my virtual inside world. That bridge is called nothing but the shared Ethernet adapter. Yes. So through the ACA, that means my LPAR will communicate with my virtual ACA. Virtual ACA will pick up that LPAR packet and that packet will travel to outside my. So that's why the point is here IO server partition provides layer 2 bridging using shared Ethernet adapter. Each shared adapter can support 16 virtual Ethernet. This is my IP network. This is my physical network. This is my virtual IO server. But mediator is required. That mediator name is virtual IO server, or in short, we can call it VIO server. So physical adapter, physical Ethernet adapter, I have assigned to my VIO server. On that VIO server, I have created one bridge. That bridge will talk to my virtual Ethernet adapter, and that bridge will communicate to. So why there is two VIO server? It is because if my one VIO server goes down, same network I will be able to access from the What about the disk? Virtual SCSI. One physical drive can appear to be multiple logical drive learns appear as a individual logical drives, minimize the number of adapters, can have mixed configuration, virtual and real adapters. SCSI and fiber supported, supports AIX VIO and onwards, version 5.3 and onwards. It supports the Linux partition as well. So what is the benefit of having virtual SCSI? The benefit of having virtual SCSI, on previous slide we have seen, if you don't have virtualization, you require dedicated I/O adapters. So for each LPAR, if I don't have virtualization, I require one FC card to bring the disk from the storage. I have a limited local disk available in server. Right? So on that local disk, I cannot give that local disk to my application. My application may grow in future, so I require more space. So that more space I will take from the SAN. So to take the more space from the SAN, you require some FC adapters, fiber channel adapters. That is called host-based adapter. That host-based adapter will bring my storage space. So what is the benefit of having virtual SCSI? If you have an advanced power virtualization license, so same physical FC adapter you can share with multiple parts. So you can virtualize that FC adapter, and that virtual adapters you can map to multiple LPARs. What is the benefit? Benefit is that I have minimized the cost of my physical FC adapter. Right? So how it will work? Right? Again, it is virtual, so I cannot directly map SAN to my virtual environment. So how it will communicate? It will communicate with the help of VIO servers. Again, some mediator is required. How it will work? It will work because all the physical resources or FC resources I have assigned to my virtual server here. Right? Again, virtual server, VIO server is here for redundancy. And I will take a SAN from SAN space from the SAN and will assign to my virtual server. Since these are the virtual cards, these are the virtual SCSI cards. So from VIO server, I can map the learn to my respective endpoints. That learn will appear as a disk in my endpoint. That learn will appear as a disk in my endpoint. So I can create a partitions and I can create partition of VIO server and I can map to the particular LPAR. That partition will also see as a disk. I can map a file also. I can create a big file and I can map that file will appear as a disk on my. Okay. So the disk I will assign like this. So I have minimized the cost of my website. Right? This is called virtual SCSI environment. This is called virtual SCSI. So again, I require the mediator VI server. Without the VI server, I cannot communicate with my virtual world. So why two VIO server is there? Why? Because one VIO server goes down. Same, my secondary VIO server will take the responsibility. My partition will be live, and I can add more space as per the requirement. So that's why what it is saying, one physical drive can appear to be multiple logical drives. Learns appear as individual logical drives. Minimize the number of adapters. Can have misconfiguration, virtual and real adapter. Yeah, that is also possible. How it is possible? So some disks are coming from the virtual servers, and some disk is coming directly from the server. Sometime you will find the type of thing. Some of the disks are coming from direct from the SAN, but the direct disk is required again. See, and on same server you can take a disk from the virtualized server. This is the benefit. This is the so internal AIX. In internal AIX, it will appear as a physical. It will appear as a physical column. So this is my virtual IO server, and these are coming from the SAN, and this is my physical SPI card, or you can call it FC card. And this is the disk drive which are coming through the SAN devices using the MPIO path or power path. You are using the multipathing software here. So what you are doing, you got the disk from the SAN. Okay. So on the top of the disk you can create volume group, or directly the disk you can map to the server, or second way you can create volume group on the IO server. You can create a LV, and that LV you can map to particular LPAR. That LV will become as a disk on your but you require virtual IO server. You require virtual IO server. See, this is the physical value appearing on my AIX client side, and it is a physical value appearing on my virtual IO side. This is bringing these of the LUNs or these of the disk. This is OM device path. This is the path I am getting from the multipathing. This is the logical volume I am creating on the top of the volume group, and this is the internal or external storage. Right? Internal storage also you can share with your LPAR, or external you can take from the storage box. You can take from the storage box, and that storage you can map as a raw, as a disk, as a file, or as a VSCSI using MPIO redundancy at client side. So another VIO server is required. See, if my primary VIO server goes down, then I am having only one VIO server. Then since it is virtualized and the disk is coming from the VIO, that means my AIX client will not able to access the disk. not able to access the disk because it is coming from the single VIO server, right? So what I will do, the same learn on the storage side I will share in between two VIO servers. So I will set up another VIO server and the same learn I will share in between VIO server. So what is the benefit of another VIO server? If one VIO server goes down, this server goes down, still I am able to access same disk from the another VIO server. From the another VIO server. This is the benefit, right? So again one benefit is there. What is the benefit? I can do like this also. One disk I will assign from this VIO server and another disk I will assign from this VIO server, right? So this will become two disks on my VIO server. So I can mirror this disk. I can mirror, right? I can mirror. If one server goes down, still I am able to access my client to the another disk. Or I can create a volume group and I can create a LV on client side. LV on client side. Either way you can use. VSCSI using LVM redundancy at client level. See, as I have already spoken. Either you can share same LAN through the both VIO server. That means same disk you are sharing. If one side goes down, still I am able to access the same disk from the another VIO server, right? Or you can do the mirroring. One disk from the one VIO server, another disk from another VIO server. You can mirror the disk, and you will get the redundancy at the client level. VSCSI redundancy with multipathing at IO servers. You can do the multipathing on client side as well as on VIO server side. If you have multipath, then if one adapter fails, the disk will come through the another adapter. Right? This is the function of multipath. This is the function of multipath. See, what is the benefit? I will not lose the connectivity with my LAN. Right? So, with the help of multipathing software, I can assign the LAN to my client. The benefit is that anyhow the one physical adapter fails, still I am able to access the LAN through the another physical adapter. So how it is happen? Because I will install one multipathing software on the web service. So automatically it will monitor my hardware. Automatically it will monitor my FC cards, and if one FC card fails, same LAN will come through the another FC card. So what is the benefit? I will not lose the connectivity with my client. No single point of failure. No single point of failure. Virtualized IO example. This is the good picture. So this is my hosted partition. It is, see, this is within my box. Within my box. This I have created one LPAR. One LPAR. So how I have hosted one partition over here. This is called LPAR. I have virtual Ethernet card. I have virtual FC card assigned to my client LPAR. So this is my hypervisor. This is my hypervisor. Hypervisor is layer in between your hardware and your OS. Hardware and your OS. So what is the major role of hypervisor? Hypervisor will assign the resources to the particular LPAR. So it will keep the track of the resources. It will keep the track of the resources. This is one kind of memory. So this is the virtual Ethernet card. This is the virtual FC card. So through the hypervisor switch, this is virtual switch I have created inside my hypervisor. Through the virtual hypervisor switch, I am able to send packet to my virtual Ethernet, which is on my virtual IO server, the IO server. Right? And this is the SCA bridge. Through the SCA bridge, that packet will go through the real physical adapter to the how I'm mapping the disk over here. I am taking the disk from the virtual IO server and I am mapping to my virtual IO card. That disk or that file or that LV will appear as a disk in my client partition. How it is happening? Through the SCSI RDMA protocol and device DLA transfer. Device direct memory access transfer and reverse DMA protocol. SCSI reverse DMA protocol. So what we will learn in the course? We will learn how to create virtual IO server. What is micro-partitioning? How to create LPAR? How to assign resources? Right? How to assign virtual cards to the LPAR? How to map the disk from VIO server to my client? Right? How to create SCA bridge on VIO server to route my virtual packet to outside physical world. See, this is the real picture of virtual. I am having some hardware here. That hardware I am virtualizing and giving to the respective LPAR. But all this functionality, all this activity, I am able to perform because of the hardware management console. Hardware management console. That hardware management console is a console I am connecting to my physical box, right? And through that hardware management console, I am creating the LPARs, I am allocating the resources, every operation I am doing to the HMC. So, HMC is required. HMC I am connecting to my managed server service processor. Managed server service processor. That will manage my entire process. Allocating the resources, dynamic allocating the resources, right? Capacity on demand. All this activity I will perform with the help of hardware management console. If the hardware management console is not there, I will not able to perform any kind of operations. Partition Load Manager is one of the benefit of advanced power virtualization. What is Partition Load Manager? Policy-based automatic partition resource tuning, dynamic adjustment of CPU and memory allocation, supported from AIX 5.3 onwards. It is supported on PowerPoint as well and PowerPoint system. So what it will do? It will balance before resource tuning, unbalanced resource allocation. If you have PLM, so you can allocate the resources as per the LPAR requirement, You can tune the resources to get the optimum performance from it. And you can assign CPU, you can assign memory, you can assign IOs. You can tune IOs to get the more optimum performance. So, with the help of PLM, automatic partition resource tuning, you can perform. What it will do? It will dynamically adjust the CPU as per the memory load. The available support available for 1.66 GHz, P56, P6570, P6590, P6995, i5 OS can participate in the shared processor pool. What is shared processor pool? Shared processor pool is that. So I will club multiple physical processors into one, and I will assign the CPU power to my LPAR from that. This is the pool concept, but only to the processor maximum can utilize VLAN, but not be a client to VIO server, not dynamic LPAR standard on P5, part of power hypervisor on open power virtual IO hosting partition is a appliances encapsulated partition available on system P5, P5 and open power. Servers and storage utilization. This is the utilization of the storage and the server. What is the value I am getting through the advanced power virtualization? So reduce the total cost of ownership by making better use of IT asset, by significantly improving server utilization, right? Consideration of underutilized workloads onto partition. Approach mainframe inspired utilization without sacrificing resource available. Economic IO model. Economic IO model. Why? No physical IO is required for LPAR. I can use shared kernel adapter, shared storage, simply IT management, rapid development of additional capacity. Improve business agility and flexibility by dynamically and automatically reallocating the resources to application as needed to better match changing business cycle or handle unexpected surge in demands. Right? Unexpected surge in demand. If you have virtualization, you can on the fly you can create one virtual adapter and assign as per requirement. Support multiple workloads, departments and application. Rapid response 10 milliseconds. Each CPU is providing 10 milliseconds to changing workload needed via shared processor pool. Automatic access to spare capacity via advanced power virtualization. Reserved capacity on demand. Explanation of VLAN. High speed communication. Scenario where advanced power virtualization likely to be have significant impact. Server consolidation of many small underutilized server legacy. Small underutilized server legacy AIX platform. Single application per server. Fractional CPU. Web, file, print. Application development, testing, secure isolation. Explanation of virtual IO. VLAN, multi-tier application. Consolidation of web application databases. Using virtual disk to consolidate relatively small boot image. Consolidation of low utilized internet. So what is the benefit? I don't need to. What is the benefit of LPAR? Logical partitioning. The LPAR benefit is I don't need to purchase one physical server for each application, right? For each application. So what is the benefit of having LPAR or having power virtualization? On the same frame, I can create a production LPAR, logical partition, or I can create a test. I don't need to buy individual servers or test environment and for production environment. So responsive OS images in shared processor LPAR with high utilization production, batch system overlapping production system, peak of value of another virtual thread environment, handle burst. So this is the what is virtualization? Virtualization is the process of presenting computing resources in ways that user and application can easily get value out of them, and rather than presenting them in a way dictated by their implementation, geographic location or physical package. In other words, it provides a logical rather than physical view of data. computing power, storage capacity, and other resources. Right? This is the benefit of having virtual. Why is on-demand important for you? Server capacity you need when you need it to help lower cost, total cost of acquisition, address your planned IT capacity growth. IT capacity growth need quickly, non-destructive built-in flexibility to address unplanned temporary spike in demand, increase configuration flexibility, increase reliability with processor and memory sparing, deploy new services quickly to react to changing business requirements, gain additional workload throughout an automated system performance. So, what is the benefit on the demand? Capacity on the demand means the spare CPUs, physical CPUs, as per the demand, you can activate at any time. So, permanent capacity of demand and temporary capacity of demand, there is two parts. So, permanent capacity of demand, you can permanently activate that processor to in your system. Temporary for 1 month, 2 months, or 3 months on the basis prepaid. It is called prepaid capacity on demand. Why? Because you need to prepare for that, and then only IBM will activate that processor. Capacity on demand plus virtualization system. On virtualization also, using the virtualization also, you can use the capacity on demand. This is the processor terminology when you are using the advanced power virtualization. What is the processor terminology? Shared processor partition simultaneous. What you will learn in the virtualization class. What is shared processor? What is partition? Simultaneous multi-threading. Why it is required? What is simultaneous multi-threading? What is dedicated processor? What is shared processor? What is logical processor? And dedicated. What is inactive processor? What is deconfigured processor? And installed physical processor. All these will cover in. So these are the benefits of having LPAR and advanced power virtualization. So who can go for this course? A person having good knowledge of AIX. That person can attend virtualization class and upgrade themselves to get more jobs. Thank you.